computers.
Oh, I thought it was just me.
No, it's just me.
Okay.
Okay. Did we lose everyone? Can't see who all's here. Okay. Anyway, let me go back to this thing here that we're doing. Okay. Okay. I forgot where we were.
So we were talking about the 3 fields and
Oh, yeah.
200 MUs.
Yeah. All right. So we got 200. Ooh, now it's red. And we're weighted 3, 1, 1. And it's PA, left and right. And I want to know what the right's getting. How many centigrade the right's getting. So again, it's dose times the weighted field that you want to know. So WF, not W, never mind, over the total fields. So we know our dose is 200, and what's our weighted field we want to know? We want to know what the right is. So what's the weight of the field that we want to know?
Which one is it? Is right?
Oh, I want to know the right. So what's the weight of the right field?
Okay.
Well, just tell me. Okay, 1. So 1 over what's our total field?
5.
3, 4, 5. So 1 over 5. 1 divided by 5 is what?
5.2.
0.2. Yeah.
Is 0.2?
Yes.
So 200 times 0.2, that's supposed to be a 2.
It's 40.
All right, so my right lateral is getting 40. What's my left lateral getting?
40.
All right, so there's a couple ways you can do this. What's my PA getting? You can add these two together, and 80, that's 80, subtract it by 200, and that'll give you what the PA is doing, which is what?
So it's going to be 120.
120.
So it's getting 120. Or you can take, also, you can just do 200 times 3 over 5 and get what? You'll get 120 also. Okay? Another thing that they were saying that maybe you guys needed some help with is like underdosing and overdosing, figuring that out. So like if a patient was supposed to be treated at 100 cm but accidentally got treated at 110 cm, what is the underdose or overdose? Would they be underdosed or overdosed if they were supposed to be treated at 100 and they were treated at 110?
Overdosed.
Overdose, why?
It's closer.
Actually,
So if it
sorry,
was-
underdose. They would be
Right.
further.
Right, so underdose. So basically we would say this is gonna be SSD1. It's another part of inverse square over SSD2. And because you're talking about intensity and distance, it's going to be inverse square. You're going to square it, okay? So if the equation was, for example, the treatment plan is set to treat a patient at 110 SSD. However, the patient was accidentally treated at 100. What is the dose error? Is that patient was supposed to be treated at 110, but got treated at 100. Is that going to be over or underdose?
Over.
Over.
Overdose.
Those.
So 110 divided by 100 is what?
1.1.
1,
1.1 and then square it.
121.
So 1.21, that's the decimal, but what is that in percentage form?
121% or 21% extra.
So 21% overdose, because 100% would be your total dose. You want to minus that by your 121. It gives you 21% over because the patient was treated closer than they were supposed to be, like if you were closer to the sun. Okay, so anything that's 1.21 whatever, that would be overdose. If it was under, answers above 1 or 100 signify an overdose. Answers under 1 or 100% signify an underdose. Does that make sense to everybody?
Yes.
Okay. Let's see what else we got. Oh, so say that a plan calls for 200 monitor units to be delivered and the doctor adds a wedge in to the calculation. What's going to happen to your monitor units? Are they going to go up or going to go down to deliver the dose?
We need more dose to compensate.
You need more monitor units because anything you put in the path of that beam attenuates the beam. You're going to have to turn up the monitor units to get the same dose to the patient. Tell me about wedge factors and tray factors. How do you figure that out? It's like the hokey pokey. In or out. Put your right foot in and put your right foot out. So you're going to take a measurement with the wedge in and a measurement with the wedge out. So if the measurement with the wedge in is 0.97 or 97% of the beam gets through that wedge or that tray, and then you take one without, of course 100% gets it without. I'm sorry, that's not supposed to be a point. That's supposed to be a 97. Then 97 divided by 100 is
0.97.
0.97 would be your tray factor or your wedge factor. So just remember with and without. With the wedge, without the wedge. With the tray, without the tray. Okay? How you guys feel about monitor unit calculations? Everybody's good? Basically, you take your dose. You want me to go over a couple?
Yes, please.
All right. So usually, and I would tell my class, usually if they do not provide a chart for you, they will give you the information that they want you to use in that calculation. Okay. So for a MU calculation, whether it's an SSD or a SAD, what chart do you use for an SSD calculation?
PDD.
Okay, what do you use for an SAD?
EMR.
All right, or TAR, either one, but yes. Let's see, 47, let's find this. All right. But you may, basically it's gonna be dose over output factor.
The PDD.
You can have S of P and S of C, scatter from the collimator and scatter from the patient. Most of the time, these are put on the same chart. This is fun. And then you'll either have PDD or TMR, depending on what kind of calculation you're doing, correct? This is the worst handwriting ever. This is like a 2-year-old wrote it. I'm doing a great job, right?
Yes.
And then
Yeah.
anything else that comes in contact with that beam, if there is a tray, like back in the olden days, we used to treat with cerebin blocks. They were mounted on a lucite tray. That's where the tray factor comes from. If a wedge is put in there, that's where the wedge comes from. That would go here, okay? So basically you're gonna take all these numbers in your denominator and you're gonna multiply them together and get a number, and you're gonna divide that by the dose, or the dose by that, okay? So, bleh. Oh, please, I lost my place. MU calculations. Here, I'll just pull some out of the back of the book. It's hard to come up with like stuff on the fly. All right, so patient treated, partial blocked. Okay, so say you got a problem like this. A treatment plan was created to treat a total of 281 monitor units. The radiation oncologist decides to add a wedge into the plan. What will be the new monitor unit if the wedge factor is 0.82? What if that's the only information you get? How do you set that problem up?
We divide the 281 by the 0.82.
Yep, that's all you do. Because it didn't give you any other information, so that's what you're gonna use, all right?
Okay.
Don't complicate it. Let's see. Here's an electron calculation. After looking over an electron plan, for electrons, all you have is the, whatever the PDD is, and the isodose line. It's, did you guys go over electron calcs at all?
Yes.
All right, so dose over PDD, because it's an SSD setup, right? Electrons. And whatever the isodose line is, 80, 90, Dmax, that's all you do for that. So for this problem, it's saying after looking over an electron plan, the radiation oncologist decides to treat the patient with 200 centigrade per fraction using 9 MeV and a 80% isodose line. Calculate the MU needed given a cone factor of 0.78 and a PDD of 0.963. We'll add in more cone factors since they added that there too. Basically, it's going to be 200 over, it gave us the PDD. Hold on. 7. So 200 over 0.963
Times point. Okay.
Yep. Points the wedge factor, or the isodose line, which was 80, right? Or 0.80, because you want to make it a decimal, not a percentage. Times, what else did it give us? Oh, the cone factor, which was 0.78. Jeez. So if someone has a FEN calculator and they can multiply 0.963 by 0.80 by 0.78, you should get some number.
0.60.
0.60, and then divide 200 by 0.60.
333.
All right, so we're gonna need 333 monitor units to deliver 200 centigrade to the 80% isodose lines with the 9 MeV cone with all those factors. Okay, easy peasy. Your photons, same gig. You put the dose over all the things. Let me find a problem with that. We could just make one up. So we'll just say, I like the problems better. Monitor units. Does anybody have any numbers that they wanna say? Oh, let's do this one. 383. All right. Calculate the necessary monitor units to deliver 200 centigrade at a depth of 6 cm at 100 cm SSD for a single field with the field size of 8 by 8 and an output factor of 985 and a PDD of 0.797. So we have 200. It gave us, the only information it gave us was our output factor, which was 0.985. That was supposed to be a point, sorry. And our PDD was 0.797. So if you take 0.797, multiply it by 0.985, you'll get a number.
.79.
And then divide 200 by 0.879, or whatever it was you said, I'm sorry.
255? 254.76.
So 255. So 255 monitor units is what it will take to deliver 200 centigrade to a depth of 6 cm at 100 SSD to that single field size with that field size of 8 by 8. Okay. Again, if they don't give you a chart, they may have like a little tab where you have to look up the charts. You guys remember these charts from the book? If you don't remember, go into chapter 22 in your Washington and Lever, and there's charts there. Do you guys know how to read the charts with the equivalent field size? So you would first find your equivalent field size, and then you would find that on the top of the chart. And then you would find your depth, and that would be along the left side of the chart. And then basically you go over and down until that meets. And then that would be your PDD or TMR, or your output factor would be the same scenario. You're gonna have the energy and the depth. But if they don't provide a chart for you, whatever information's in the problem is what you use. And you may not have all the factors. You may just have a PDD. You may not have an output factor, but that's all you use. That's all the information you have. That's all you can use. Okay? Okay. Anybody else have anything that they... What about therapeutic ratio? You guys talked about that?
Yeah.
Yes.
The good over the bad. Anything above 1 means that it's a good outcome. Anything below 1 is probably not a great thing for the patient. What about separation? Oh, what if I was treating to a depth of 6? What's my APSSD going to be?
Excuse me, one quick question. When you said about the therapeutic ratio, what were the numbers you said?
Good over bad.
Uh-huh.
Like the normal tissue tolerance over the tumor lethal dose. So if you have an outcome of 1 or above, then that means that you can treat that tissue. You can kill the tumor without killing the tissue. But if it's below 1, then that means it can be concluded that it's a favorable therapeutic ratio if it's above 1. If it's below 1, then that means it's bad. It means it's going to take more dose to kill that tumor than the tissue surrounding it can take.
Perfect, thank you.
Mm-hmm. And then what did I say? I don't remember now.
You were talking about
Oh,
if you were
separation.
treating- yes.
Yeah. So if you were treating someone from the AP and you were treating to a depth of 6, SAD to a depth of 6, what would your SSD be on the skin surface? So
Is it 94?
Yep, 94. So if this is my patient, the separation is from here to here. Okay. If I was treated to a depth of 6 right here, and it's SAD, so 100 would be here. Then basically your source is here. So from here to here is 100, right? SSD, that's isocenter. What would my SSD here would be? You just have to count the 100 minus the depth, which is 6. So that would be 94 to the skin. That makes sense?
Makes sense.
All right. If I told you that we're treating a patient that is a separation of 20, that means from the entrance of the radiation to the exit, that's how thick the patient is. What is and we're treating them to midline, what is the APSSD? So their separation is 20. So midline would be what?
10 and 10.
It would be 10. So what would my SSD be?
90.
Yeah, what would my PA SSD be?
Same.
Correct, because you're treating to midline. What if the doctor moved the isocenter 1 cm anterior? What is my SSD on AP?
89. Yeah, 89.
Okay, what is it on PA?
91.
Correct, because the patient moved 1 cm up. The table moved up 1 cm to move that. I'm sorry. No, we're backwards, because to move it anterior, remember isocenter never moves. The table has to move. So in order for that isocenter to move up, that means the patient has to drop. The table has to drop 1 cm. So this will be 91, and this would be 89.
Correct.
Right? Makes sense?
Yes.
Okay.
Yes.
Let's think of another one. Oh, I know another one that people get tripped by.
91.
Malik, if you're still there. You still there, Malik? Oh, he had better things to do. Here's our gantry. Here's 180 at the top. 0 at the bottom. 90 at the patient's left, always 90. 270 at the patient's right, right? If my patient was prone, what would you call this angle at 300?
LPO.
I'm sorry, that's not even 300. I'm sorry. It's getting late, you guys. What would you call this angle at 200?
That will be LPO, right?
So if my patient was prone, so if my patient starts out supine, and this is the patient's left side, this is the patient's right side, and they flip over prone, you're going to call that, you said LPO?
Oblique.
Right, a left posterior oblique, because the patient is prone and now their left is over on the right side of the table because they're prone.
Yeah.
What about if it was 300? What would it be called? And the patient was prone.
Left anterior oblique.
All right, what if the patient was supine? What would 300 be called?
Left posterior oblique.
Think
Left.
about it. The patient's supine.
Right.
Okay. So it's at 300. That would
Yeah.
be right. That would be right posterior oblique. Yeah.
Yes,
Right
because it's
posterior.
coming in at the patient's right posterior side. It's beam's eye view. Does everyone understand that?
Mhm.
You're
Yeah.
gonna see stuff like this on the test. Don't let it mess you up because they're prone. Even if you have to draw an R and an L on your hand and flip it over, picture a Barbie doll or whatever you got to do. Don't let it confuse you, and make sure you read the question and answer what it wants. Can you guys think of anything else that is racking your brain? No? Okay. Well, if you guys have questions and you guys want to meet back on here, I'm willing to do whatever you guys want to do. I can meet you guys on here anytime, okay? I don't know if
Okay.
I don't know if it was helpful or not, or you can email me, or I can give you my number. You can text me. Whatever you want to do. Do you guys want my phone number?
Yes.
All right, 386 852 6974. And then my email, let's see. Jessica doesn't know how to spell my name, so it's Erin. Oh, I think it is. I think she did spell it right. Yeah, Erin.Flannery, FLANARY @cambridgehealth.edu. I think that's what it is. Okay,
Okay. Thank you so much for your help.
you're welcome. Good
Thank
luck,
you.
guys.
Thank you.
You're welcome. Bye.
Bye
Thank
bye.
you. Bye.